This is a quick video about how to set up to use the photogate through the Arduino interface. I was particularly interested in the aerodynamics effect on the thing, so weight mattered. I had a little scale, measured the bob in grams. I would use the same shape thing, both empty and full, and then I could tell from the degradation, how speed degraded, what the effects were. But back to setup. So you're going to need Arduino on some kind of a laptop, and you need to go out and get the software. So the software came from, it was originally something I found at sparkfun.com, but it needed so many changes it's not really that recognizable. But there's no real problem. It wasn't. They did some clever things, and I reused their cleverness. So you need USB port attached to a shield. This shield does some pretty simple things to connect. This is a line right here that goes to the photo gate. So I took a 6-pin. I think they're called IDC cable. It's phone company stuff. There are 8-pin versions for Ethernet, 4-pin versions for phone, and I'm not sure where 6-pin fits in that taxonomy. But anyhow, this is a 6-pin connector. I got this cable at Fry's, cut it in half, opened it up, I made my own connector here. And these go, I'm using the SparkFun pinout to use their interrupt service routine. That I thought was pretty clever. So I had some other debug stuff on it. This little resistor right here, if it goes between A3 and ground, chooses something different in this software. That's no big deal. I ran the principal data without it connected. That thing could be pulled out. This happens to be, this is my numbering convention. So this is an Arduino Uno, 16 megahertz, and I number my shields also. So these two, the shield is just plugged in on top of this thing. During development and actual use, I'm using this USB cable. I don't think you need to know any more about that. So this is a stock photogate. I didn't have a pinout of it, but if you ask me, I'll give you a project document that'll show the schematic and how this thing had to be pinned out here, or you could just borrow this whole unit. I'm hanging it from a tripod that I usually use for filming things, video adapters on it. And so what I found in actually trying this was that there was a lot of precession. The thing would start out one way and go another. So that turns out to be my, if I ever get back to this, I'm going to go look at that precession stuff, because I thought if I just oriented this the traveling line east-west, it shouldn't precess, but perhaps I was giving it some initial jerk. I'm not sure. So anyhow, so this Lazy Susan here I got at Tap Plastics is just to handle the precession. I wanted the line of its motion to always be perpendicular to the line of the sensor. So if during a run I would watch it and I'd change it as necessary. So other things in the data that I use to get these graphs, I learned over time not to use every pass through the photogate. I use the outbound only. So I wrote a script. So this is what was happening if I actually look at the raw data, both passes. There'd be a little bit of an offset, physical offset error in how the thing approached the sensor, and that would make it shorter on the inbound versus the outbound or something, and I'd get this wavy thing that was, it just made it more difficult to see what was really going on. So I wrote a little script. I take all the numbers with this software, and then I write a script that just strips out every other one. And that's what generated these plots. And what I did to prove my aerodynamic point is I went into both data sets. So I've got a data set at the vial empty that made it 62 grams, and then I have one where I filled it with water that made it 96 grams, and I find a speed in one data set, and I find it in the other data set. Note the time. I go for a slower speed after it's degraded some, and find the same things. And then, since the time difference was very different, it was much faster for the 62 gram to slow down. So I felt like I had proven my point. So anyhow.